I have received a few requests from my Patreon supporters about how you would add animated characters to the game and also replace the in-game graphics with better models. So I've downloaded a couple of models from KayKit, Minigame Variety and KayKit Adventures. The Adventures kit contains animated characters and both of them are free, and I will add a link in the description. Let's start with replacing the character. So in our resources we have DB and character controller entity. And in here we have the models that are currently used. So instead of these, let's just delete them. Instead of those, we're going to use the KayKit models. So let's go and find characters, FBX, and let's use the Rogue one. As well, here we have the Rogue, and we are going to remove a couple of things from the rig. So let's open hips, spine, chest, upper arms left, and disable all of the things it's carrying in that hand and the other as well. Then we will get rid of the cape, which is attached here. And the next part is that we need to adjust the size of our collider so it matches the size of the character, and we are not going to use a sphere. Instead we are going to use a box. So let's change the size of the box. Extends 0.5. I think 1 in height will be okay, 0.5, and we need to bring it up a little bit. And maybe 0.5 or 1 was a little bit, no, actually it fits it well. So this is the new character, and all the other things we can leave as they are. So let's just save it, and then we can try it and see how it looks in game. So now we have our characters and we can move about, and they are in their T-pose and we can jump, and they are working as they should. So now we want to add some animations to our characters. Let's go and create a new folder, call it animations, and here we need to add an animated controller. So animated controller, and we'll call it character animation controller. And this one needs to be used by our character. So let's open our character again, go into our model here, add animator, and then drag and drop our animated controller. And then double click on the animator controller, and we will as well save it. So make sure that you have saved the character. So now we have these states, and we need to find our animations. So let's go in FBX, and we have our, not the hooded one actually, the one without the hood, and we are looking for our idle animation. So let's pick our idle animation. So when it starts, it's just going to go into idle and do nothing. So let's try it and see that it works. So now we can see that our character is no longer in T-pose, and we can move it around. If we have a look at our animator and we select one of our entities and pick the Rogue one, then we can see that it's looping the idle. So now we want to add as well a movement animation. So let's find our, we can either take the running, but I think I'm gonna go with the walking instead. So let's pick walking A. And we want it to transition from idle into walking A, dependent if the character is moving or not. So go into parameters, add a new bool, call it is moving, and we are going to make a transition if we are moving, then we are going into our walking A here. So let's unclick has exit time, and we need is moving is set to true, and then we need to set a duration. How long time is it going to take for us to exit our idle and go into our walking A? So instead of fixed duration, let's make it that it transitions in 0.1 or 0.2. We don't need to rush it that much. So we can see that this will be the blend. It will continue and then it will blend over into our walking animation. And once we have started to walk, we want it to loop, and once we have stopped walking, we want to go back into idle. So here as well, let's check condition is moving set to false. Unclick has exit timer, and when we are stopping, we want it to be slightly faster, and untick fixed duration. Now our walking A animation, if we have a look at our walking A animation, we can see that it has loop time selected, and the same for idle. If it doesn't have that for some reason in the animation you're picking, then you need to change it, and you can do that by selecting the character and then go into animations and find your animation. Let's say that we have this block hit here, and in the bottom you can check loop time and apply. But our idle animation, if we can find it somewhere, idle is already set to loop, and the same with our walking A. So that should be all fine. Then we need to feed our animator with the parameter is moving, so it can transition from idle into walking. And for that we need to change our code. So let's find our scripts and open the player handler in Visual Studio. So the first thing we're going to do is add a state is local player, and we are checking here if we are the local player. So we are going to store that as true. We will use this when animating, and so it's easy to have that. So let's add a void update to handle the animation, and we need to get our animator to be able to handle this. So let's make a serialized field, animator, call it animator. And in our update function, we need to collect the information from Quantum. So let's grab our Quantum stuff like we have done before. So var game, Quantum runner default game, just like we did here. And then we are going to get our verified frame or the frame. And in this case, we are going to check if we are the local player, then we are going to get the predicted frame. If not, we are going to get the verified frame. Then we need some type of movement. So we need to figure out with the animation if we are moving or not. And we are going to use var movement and get it from frame get character controller 3D entity view entity ref. So instead of doing try get here, we are just getting it, and if for some reason you haven't added a character controller, this is going to throw an error, but we assume that you have done that, so we're not checking for it. And after this, we need to determine, okay, are we moving or not? And we can get this from the Quantum side. So if we look at our movement here, if movement, and then we can check velocity, and we can check the magnitude. If it's bigger than 0, then it means that we are moving, and if we're not moving, then we're standing still. So let's take our animator and set our bool is moving to true, and if we're not, then let's set it to false. And then let's save this and try it in Unity. So let's open our resources DB character controller. We need to assign our animator. So let's drag and drop our animator and let's save it. And then go into scenes, hit play, and we'll see if it works. So now we have our character and it's in idle, and if we move to the side we can see that, yay, it's moving. And if we're jumping, then it will keep on walking. So now we have the basics of our animator. We can stop moving and it will stop. So we might want to add some more animations, like a jump animation or a falling animation. So let's stop our game, and in our animator let's add a new parameter, and in this case we are going to do another bool, is falling. So we're going to use the same mechanic for jumping and falling. Whenever something is either jumping or falling down, then we're going to trigger this animation. And we are going to use several animations for this. So let's find jump idle, and then we are going to use jump land. So the idle animation, if we have a look at the idle, it's just the arms stretched out and it looks like, well, it's kind of falling. And the land is some movement downwards, and it looks like it's hitting the ground. So again, we need to transition into jump idle from idle here. So make a transition and remove has exit time and add R is falling. And let's set it to not fixed duration, and I think a quick change here, 0.1 into that. And then once we have landed, we are going to make a transition, and then we need to remove this exit time and check that is falling is false. And fixed duration, once again, let's set it to 0.1. And then when we have landed, we are going to transition back into idle. And this one can be fixed because we don't need a condition for it. Instead, we are going to just exit, but we are going to exit a little bit faster as well. 0.2 might be good here. So dunk and exits. And then we need to make the same thing for this transition, make transition, and use the same parameters as we have here. So let's remove that, and condition is going to be is falling, true, and the transition duration is 1, remove fixed. So that looks correct. So now we need to make sure that our jump idle here is actually looping. And as we see here, it's actually not checked, so it will just play once. So let's change that. Roog, and where are we? Walking, running, pick, throw, blocking. There we have jump idle, and then check loop time, apply. Alright, so now we need to make sure that we change our code so that it can handle that case as well. So let's go back into our scripts and open Player Handler in Visual Studio. So let's add a check here and see if the movement is grounded. In that case, we are going to allow the updating of movement. And if we're not grounded, then we are going to set animation is moving to false. And in our case, when we are not grounded, then it means that we are airborne, and vice versa. So if we are grounded, it means that we are no longer airborne. So this will give us the ability to detect if we are grounded, and in that case we are not airborne, but if we are airborne, then let's set it to true and it's moving false. So let's save this and try that in Unity. So let's hit play. And oh, we have an error here. Parameter is airborne does not exist. Okay, yeah, I made a bit of a mistake. I called it is falling here, but in the code I called it is airborne. And it's actually better with is airborne, because falling means that we have fallen down. Airborne just means that we're airborne. So let's keep is airborne instead. So now let's try it. So we can see, okay, we are airborne, and because we are starting in there, so that was good. And then when we are jumping, it's going to do this falling animation. So that's good. And if we are falling off a ledge, it will do that as well. Awesome. So now we have some movement, and in our game it could be that maybe we want to do some other cool things like sprint. So how would we do that? Well, first of all, we need to adjust our animation so it's animating faster as we are sprinting. And maybe if we're going downwards or something, we will move faster. So we need our movement speed to adjust to how fast our character is going. So let's add that. So in our parameters, let's add a float movement speed. And let's use small letters so it's the same everywhere. And our walking here, let's override it with a multiplier parameter movement speed. And let's go back into our code so we can add that. So here, when we are moving in our code, we want to be able to set our movement speed. So in this case, we are going to do animator, set float, and we call it movement speed. And the number that we are going to use is movement, velocity, magnitude again. And then we have some error here saying that it can't convert from photon deterministic float point to float. So let's help it with a cast. And so let's save that and try this in Unity. So now we have our falling here. And now we're moving. Hey, look at that. Now it's moving a lot faster. So if we are going like slowly, we can see that the feet are going more slowly. And if I'm holding it down, we can see that it's going fast. And then we can do our falling. Perfect. And we can have a look at one of the entities and just check our animator. And let's dock it somewhere else so we can have a look at let's put a game like this, and if we are moving, we can see that, okay, we have our walking animation, we are jump idle and jump land, so we can see that it's changing between the different states. So now we have full idle, now we're walking, and now we're going back in this. And we haven't checked this has exit time, so it's using our duration of 0.1 here. So that's good. So now we talked about dashing. So let's assume that we want to be able to dash in the game for a short period of time. Then we need to make some changes on the quantum side first of all. So let's go quantum, open quantum project. So let's go into our input QTN and add a new button, and we'll call it dash. And then let's build it so it finds the QTN file, and we can use that in other systems. Then we have our movement system here, and this is where we want to be able to do some dashing in our game. So right now we have this parts where we are moving here and we are jumping. So let's add another check here. So if our input dash, and instead we are of checking was pressed, we're going to check is down. So if somebody is holding down the dash button, then we want to do some things. And we want it to move faster. So go filter, character controller, and change the max speed to 6, which is twice as fast as the regular. And if we are not holding down our dash, then let's take our filter, same code here really, and put it to 3, which is the default. And then let's just comment it, dash. So if we would try this in Unity, it would work as long as we are adding support for this input collection of the dash. But maybe we want to make it a little bit more interesting, like having a dash meter, so you can't dash all the time. You can only dash for a certain period of time. So how would we go about doing that? Well, we're going to hack it a little bit. So let's find our player link qtn file. And in this, we are going to add a parameter. We already have our playref player here. So this maybe should be in its own system with its own qtn, but we'll do it just quick and dirty. So byte dash meter, and let's build it. And then in our movement system, we are going to use this dash. So first of all, we need to figure out when we are starting up. We want to set our dash to something. So in this case, when we are collecting our player link here, let's do player link and then dash meter and set it to 255, which is the largest value of a byte. And then we are going to check here when we are doing our dash if we are allowed to do it instead of just doing it right away. So if we are trying to dash and at the same time we have our filter, and then we need to get our link and our dash meter. If it's larger than 5, larger or equal to 5, then we are saying that, okay, you are allowed to dash. And while we are dashing, we are going to reduce this dash meter by 5. So take the filter link dash meter minus equal 5, which reduces 5. So it can become 0, but not less than 0. So if we have more than 5 in our dash meter, then it means that we can dash. And we would like maybe this dash meter to refill. So while we are not dashing, so we'll do the same check here. If our input dash is not down, it means that we are no longer dashing. In that case, we are going to increase our dash while it's less than 254. So, or actually 255. So if it's lower than 255, which means anything below 254, or below 254 and down, then we are adding 1 to it. So that will refill it. And as well, if we are falling outside of the world, then we are resetting the position. So let's reset the dash meter to be 255 as well. However, there is one more thing that we need to take into account in our code. When we're reducing our dash meter by 5 here, we are not considering that this could run multiple times per frame because of prediction and rollback. So we need to make sure that this is running at a fixed update speed. And if we check F is verified, then we can actually run this at a fixed update, because is verified is going to run at a fixed speed. So by doing that, we can ensure that our dash meter is not getting reduced by too much, and as well the dash meter is not being added with too much. So we are using to check here as well to make sure that the frame is verified. Okay, so now we can go into Unity and add support for actually sending the dash information to Quantum. But before that we do that, let's build a solution. And now we can go back into Unity. So then let's go into our settings, project settings, and then input manager. And we have access here. Let's change the size here to 19, which adds another cancel here. Instead, we are going to call it dash. Positive button is going to be left shift. And let's remove that. And it's not going to be axis. Actually, we type is key or mouse, so that's correct. And let's close this. Then we need to use that. So in our local input, we have that script here. Let's open that. And then we have our get access here and jump. So maybe after jump, I dash is equal to, and then let's do the same thing, Unity engine get button dash. Let's save, go back, and now we can give it a try and see if it works. So let's see. Okay, so now we're moving in normal speed, and let's hit the dash, and yes, we dashed for a little bit. Awesome. So now we can dash, and if I'm hitting the dash all the time, whoops, well, I got my stick keys, then it actually does not dash. Rather, it needs to refill for a bit, and if I fall off the world, it's gonna give me a full dash again. So now we have some cool dashing. Let's make a little bit more interesting level. So in our scene now we have this big ground, so we will use Kay's assets instead. And let's just pick and find the game variety pack, and then FBX, and then we are going to use hold on, tile large, no, tile low maybe, hold on, how does it look? Yeah, tile low forest, and it looks like this. And let's make it a size of 3, so we're gonna make them slightly larger, and then let's align it with the world, and I'm gonna check this so it moves well with the it moves with a value of 1 instead of a dynamic value. And I think this will be okay for the start position. Then we need to make sure that Quantum can handle this. So let's add a Quantum, and we are going to use a static mesh collider. So this is going to use a fair amount maybe of computation, but it will add a cool effect because this is rounded. So it means that we will have slightly rounded edges. Just make sure that the tile low is set as the same here, and then the other settings we can leave them as they are. And let's make a prefab out of this. Prefabs, and let's call it level. And then let's use this as the starting point for the players. I think this will be okay. And let's remove the ground so we can see what we're doing. So here we go, and let's make it as wide as it was. So we can handle all of our players, something like that. So let's hit play and see that it actually works. And we can see that, yeah, Quantum has found it and is showing all the bits. So now we're starting on it, and we can walk, and it falls down a little bit between. So it looks cool. And we can jump into that, and the others fell down. Awesome. So let's build some level from this. So I will do that, and I'll get back to you shortly. Alright guys, now I've built a slightly insane obstacle course, and let's turn off the gizmo so we can see how it actually looks. And I've added some slopes, and well, the player needs to jump here and go through that, and then I've added these small gate wide that you can walk on, and then the goal is to reach the flag, which is using our quantum static box collider as before, with a trigger. So whenever they're reaching this point, it's game over. So let's try it out. And this is using 25,000 triangles, so that's not very optimized, but yeah, it will work. So we'll clear the first jump, second jump, and then jump and dash, jump and dash, jump and go over this. And then jump again, and don't fall over, and jump, and dash, and then I think you can just dash the whole way. Yay, I made it. So that's cool, but it would be nice to have some indication how much dash power we have left, so that we know as a player. So let's add that to the UI. So let's find our in-game UI canvas, and it's actually not a prefab, so let's make that into a prefab UI, and let's put it there. So now it's at least a prefab. So we have our game state here, and let's turn on our gizmos again, and we want some dash indicator. A slider is something that we will use for this. So let's go UI slider, and then we have this slider here, and let's zoom in. So let's replace this with our own graphics. So the handle, we're not going to use that. Background, let's change that into the blue, not button, let's use panel, and it's sliced, so that's good. And then the fill area, let's do the same thing, replace it with I think we're going to use actually the same one, so blue background panel. And the background area, let's make it darker, and the fill area, let's keep it at that brighter. And let's check our slider. So we want it to slide left to right between min value and max value is going to be whole numbers and 255. And if we try it now, we can see that okay, it's going up, but not all the way. The reason for this is in the margins. So if we look at our fill area, we can see that okay, we have our fill area here, and it has this left 5, right 15. And if we put it to 0, it did overfill. So maybe 5 is a better choice. So now I think that if we bring it up to full, it's gonna be full. And then as it's going down, we can see that it's going to decrease, and then it's this size because that is the size of the width of the fill area. So if we want it to be smaller, like 1 or 0, then we can have that, but we need to adjust the margins again. So let's have a look at our fill area. The fill to the right in this case, or left, let's put it to 0. And let's check that it fills all the way up, and it didn't, so now it sort of makes more sense why. And fill area right 0. Okay, so now we have a decent slider, and maybe it needs to be bigger though. So let's make it 50 to 100. Let's just check the fill again so it works. Yay. Okay, that's good. So let's leave it at something 50 and save and go back into our game and have a look at our game view. So it'll be good enough, but I think you could make it probably even larger. Let's make it larger. Slider 300 and 100, so it becomes fat. Save. This will be good enough. And then we need to program it so it works. So let's go into scripts and UI and open our in-game UI handler. So then we need to add our slider here. So serialize field, slider, and it added using Unity engine.ui, slider, dash slider. Then when we are getting our frame, we have our frame here, and we need to figure out, okay, how are we going to get the player handler? So we want the player handler as this is indicating how much dash power, etc. that we have. And we can access it directly in our UI handler here if you want, but we can also grab it from here. So I think I'm gonna do the opposite. I'm gonna add it from our player handler. So let's make something that is easy to grab. So let's do a public static and player handler, and we'll call it local player handler. And this is going to be set when we have found our local player. Okay, so now we have that, and our information is here in our player link. So we have our player link that contains our dash meter, and that is only received when we are doing our instantiation here. So instead we need to make sure that we have some type of function that can get it for us. So let's do a int or byte dash meter, put it to 0, and this, let's update it. So when we're getting our update here, let's do the same thing that we have done here. So instead of getting this, let's do a var, and we are going to find our player link, get player link, and let's call it player link. And our player link, we are going to check our player link and see that, okay, dash meter, our dash meter is going to be equal to our player link dash meter. So this will be updated whenever this is called, and yeah, that will work. And then we need some type of way of getting this. So let's do we'll just do the dash meter byte. So we'll expose it as a property. So in our in-game UI handler here, we can get our frame, it doesn't matter. So instead we are going to check if player handler.local is not equal to null, then we'll go ahead and we'll take our slider, oops, not our slider, our dash slider value is going to be equal to our player handler local handler dash meter. So let's save that and go back into Unity. Then let's open our canvas and make sure that the slider is assigned. So There we go, slider. And let's actually rename this to dash slider. Save, and let's try it. Alright, so now I'm dashing and it's getting refilled. And let's dash again. Yay. So now I have a bit more visual indication of what's going on when I can dash and when I can't dash. That makes it a whole lot easier to play this game. And of course, as this is Quantum, this will work. So let's compile a few clients and give it a try. So I've invited another player. So let's start game. And there we have player 1 and 2. So yeah, I can push him down and move around. And then the other player started to run around as well. So let's see if we can complete this course. Yeah, so you can push around, have some fun, and let's see who wins. Oh, you try to go for it. And no, I missed. Oh, okay, damn, he won. I'd like to give a shout out to our Patreon supporters. It helps us with every single contribution that we can get. So please consider supporting us on Patreon. The link is in the description. Thanks for watching, and don't forget to like and subscribe. I'll see you in the next video.